Hi. Today I'll be presenting the final project for CS 6800. So this project generally entails creating a knowledge graph for amyotrophic lateral sclerosis. Um, it's a neurodegenerative disease, and it is quite an impactful in today's climate. It is actually um, It results in gradual weakening and atrophy of muscles throughout the body. This leads to a lot of difficulties in speaking and eventually even breathing. The exact cause is unknown, and so there is also very little research in this area. Unfortunately, there is no cure for this, which is why this project is quite relevant. The aim of the project is to create a centralized repository for all and everything and all information related to ALS in the form of a knowledge graph. And this knowledge graph will be machine readable, allowing enhanced accessibility for researchers in their future projects. The traditional method, when we talk about the traditional method on creating a knowledge graph, it is mainly involving domain experts who will sit down and go through peer-reviewed research and manually select triples that will be added to the knowledge graph. Now, obviously, um just by even in the first time when you hear something like this, it's very easy to understand that this is a inefficient and extremely high cost method to perform the creation of a knowledge graph, which is why in this project we approach this problem with a new machine learning approach uh, to create a knowledge graph. Before we dive deep, we can quickly just go over what research has been done. D Ovidio in 2019 did disease progression prediction using machine learning models. This is in a way somewhat relevant because the progression prediction is can be crucial, and I think the most important part of a analysis would be to be able to determine how quickly a disease can progress based on certain parameters. If that prediction can be done at an earlier stage, that can be crucial. Another important paper was done by Rosenaz, which they had built a knowledge graph for another neurodegenerative disease. Um, Renotomy had performed natural language processing for patient-doctor interactions, specifically for ALS. That happened in 2020. And with more work in this specific manner, the machine learning approach, if we can apply more work and with more direct integration into ALS research, this can turn out to be this can turn out to help researchers skim out a lot of years worth of research simply by giving them a centralized repository that they can access and is usually updated, something like about a month every month with new literature added to it. Now we can dive deep and have a look at what the approach is. Essentially, the approach is broadly divided into these um, five processes, corpus selection, entity extraction, entity merging, relationship extraction, and KG validation. Now, um, corpus selection is just the process of selecting relevant literature. This project, the importance of corpus selection is quite important to a project like this, because this project aims to remove the or at least decrease the involvement of a traditional expert. So it is important to have relevant corpus, and if the data and the entities that are being extracted are from a relevant corpus, that mostly defeats the purpose, which is why corpus selection is a very crucial initial step. For this, I have used PubMed library. I have gone on and downloaded the JSON files for individual articles that are relevant based on keyword searches that I've performed, and I've used those JSON files to do my other work. Next up is entity extraction, and entity extraction essentially it's as it is what it means. We basically go through those JSON files one by one and then um, extract the annotations that are performed. And for this, I've used PubData as mentioned in the project proposal as well. PubData is an annotator tool which is already trained on relevant healthcare data, and so it is very good at identifying what is a relevant uh, term in a medical article, whether it's the abstract part of the article or the body, or even if it's the title. PubData can give you an annotation for each and every part of that. Interesting thing here to note is those entities that we are extracting all have mesh IDs, which is essentially a unique identifier for each term. And what PubData also does is that it actually goes on and merges semantically similar entities or terms. So let's say if we are talking about, in our case, amyotrophic lateral sclerosis, and then the shorter form for this is also called is ALS. So if you go on and look at PubData, the mesh ID for um, ALS and amyotrophic lateral sclerosis, it would be the same thing, which um, indicates that PubData is able to understand semantically similar uh, terms which don't look alike but are they mean the same thing. And so this will be crucial in the next step, which is entity merging, where we want to remove deduplication and irrelevant entities, which are basically mean the same thing. And as I spoke about those mesh terms, that is what I'm doing in this process. In this part of the whole process is I am actually filtering out the entities I've extracted for each article based on a unique mesh terms that allows me to create a unique entity set that will only have um which will only have entities with unique mesh IDs, thereby removing any possibility of deduplication. Now, obviously, this mostly depends on how well PubData performs in the whole concept of mesh ID. But as far as I know, and from what my experience has been with PubData, I think it's fairly reliable, and mostly I've seen good results. That it does not tend to um, give a different mesh ID to a semantically similar term. Next up is relationship extraction. This is probably the most important and crucial part of this project, where we are actually trying to focus on creating those triples. finding that relationship among entities. This is what the knowledge graph is all about. And for this, I intended to use two models and create an ensemble model from them. The two models are Stanford Open IE and Ernie Health. The first one is a natural language processing pipeline created by Stanford, and it's open source, and it's um, Java. It's built on Java. And Ernie Health is a large language model that's trained on patient-doctor interactions. And this is a more general model. There, based on my research, I've seemed to found that there are many different sub versions of Ernie Health, that some of them may be more relevant. Unfortunately, this is where my project really breaks down. Unfortunately, I was unable to complete relationship extraction. Essentially, I started off with Stanford OpenIE, and I had a hard time getting the code to run the way I expected it to. And when it did run, the triples that it was giving me were mostly irrelevant. My solution to this was to use those relevant entities that we have extracted before and then again filter the triples um, based on the relevant entries that we have on hand. In that case, if we have an irrelevant triple, um, the only way a triple is selected is if a relevant entity is either in the head or the tail of the triple. And that way I intended to make it work, but the code part or the coding part of Stanford OpenIE was quite difficult. More than that, I expected it to be. The runtime is in Java and it tends to create a server every time it queries for triples, and that seems to crash the kernel. I was specifically working in um, a Python notebook, and that seems to break the kernel almost always, or either send a timeout exception. And so that's where I could really not work with it. Next up is KG validation. This is again a very important final step of this whole process where um, even if we do manage to generate a lot of triples and that may look relevant, they might not actually be relevant, and which is why this process comes in the end to actually filter out those ones which do not make much sense. These triples, this validation step, um, little research. I found almost little research on how you can validate triples in an automated machine learning method like the one that we are using here to, automate the process of validation. One possible solution that I thought of this was to incorporate um, the article where or the article number, or some idea of the article from which the triple is possibly extracted. Sometimes a triple might not actually originate from the same article, even though like the entities may come from that. But this is a possible solution. Of course, I've not implemented it, so it's hard for me to even um, confirm if this can even work or if it is feasible in any sort of way. But yeah, KG validation, knowledge graph validation is another very important step because we are not the domain experts. And I think it again comes down to being able to involve domain experts into our um, process, because I guess without their expertise, it is almost very difficult to at least automate something. To be able to automate something, you tend to usually use supervised machine learning models, and supervised machine learning models have concrete data to learn from what is good and what is not. In this case, we don't really have that. So domain experts will need to come into play, whether it is in the corpus selection or whether it's in the KG validation. I think domain experts are needed for a project like this. Maybe not end to end, but to an extent, they can definitely help. Overall, the development of an ALS KG is very obvious. It's there. The amount of research in this field is very minimal. And the amount of research specifically for ALS is also very limited. The knowledge that as as the research community has for ALS is also very limited. And every day there is some new article coming in every other journal in the medical field that is showing something new that they have discovered for the ALS and the effect of a certain drug on the disease, on the progression of the disease, on certain stage of the disease. And so a knowledge graph is going to be crucial for sure. Coming back to my personal work in the project, I've unfortunately I was unable to complete the project. Most of the problem came in the relationship extraction part, where the Stanford OpenIE gave me a hard time, and I could not really work with Ernie Health to give a strong answer of how whether Ernie Health also has similar problems or not. I did find, I'm sure there are better techniques that can be done for entity extraction also. I think they were mentioned in the proposal. But I was again not able to implement them. Those are mostly just sets, different set queries that involve genes, and drug names. That way, maybe we can extract more relevant entities. And triple generation. Now, of course, we discussed trying to create an ensemble method with um, two models, the Ernie Health and Stanford OpenIE. But I personally believe to create an effective model of such sort, probably the best thing to do would be to include or at least train indeed a dedicated model only on ALS data. This could this could be a neural network or a some sort of large language model, something of those sorts. Of course, it has to be natural language. And if we create something where we are specifically training it only on ALS, now recently OpenAI has introduced GPTs, which are smaller models specifically trained to work on smaller tasks. Maybe we can train multiple GPTs to learn different aspects of the ALS disease and then try to somehow combine them into one model that can effectively annotate and understand ALS literature that is coming in day in, day out. And again, yeah, KG validation was harder than it looks. Unfortunately, I didn't really get around to do more on that. My thoughts on this project is I learned a lot, and this field is definitely ripe for research. There is great scope, and I would love to work on this kind of a project again uh, in a more realistic approach, probably smaller tasks handed, maybe. And the theoretical aspect, I do really understand what is needed in such a project, but the practical implementation is definitely far from it. I think more time needs to be set for practical implementation and smaller goals to achieve for the practical implementation. Again, yeah, the project is doable and just needs more time. Yeah, and that's the end of it. Thank you for listening to my presentation.